So I want to show you kind of the application of doing this. We got this standard form. We brought it down to factored form. But why? Why would we do something so ridiculous like that? Well, here's the advantage of doing it. I want to show you real quickly the zero property term, or the zero product property. It's very simple, easy thing to understand. I even think I explained this to you once before. If I have two numbers, A and B, and I'm multiplying them, and I say that A times B equals 0, I can draw one of two conclusions. I can say that either A is equal to 0, or B is equal to 0. Does that make sense? Because if A were 0, that would be 0 times B equals 0. That's always true. Duh. Or A times 0 is equal to 0. Yes, that's always true, because anything times 0 is 0. So I can if I see this statement right here, A times B equals 0, then I can either say A equals 0 or B equals 0. There's nothing wrong with that. So something times another thing equals 0, then that first thing is equal to 0, or that second thing is equal to 0. Right? Well, we can apply that idea to this. This thing times that thing is equal to 0. So either x plus 3 equals 0, or x minus 5 equals 0. Right? And I can figure out what x is. X is equal to negative 3, or x is equal to 5. I actually think I covered this with you last chapter. Do you remember this? I'm not even going to ask. So your answer is either x is negative 3 or x is 5. There's kind of a shortcut to doing these. What are the solutions to this? X is equal to, I know you know this. What is x equal to if I, what is that? Nope. X equals 9 and x equals negative 1. No, I'm not talking about foiling. I'm asking you what x values make this true. You would say either x minus 9 equals 0 or x plus 1 equals 0. Solving for x, you would get x equals to 9 or x equals to negative 1. This is exactly the parabola things. I told you I taught you this before. What are the solutions to this? X equals what? Come on, Jordan. X equals negative 1. Where are you getting 1? X. I would either say x plus 6 equals 0 or x minus 6 equals 0. X equals to negative 6 or x equals to positive 6. Because I take this and put it on that side, it becomes negative. I take this, I add 6 to both sides, it becomes positive 6. We good? So check this out. If I wanted to find, how do I find the solutions to that problem? Well, here's what I would do. I would say, all right, well, let's try factoring that. Here, let me ask you this. 11x plus 30 equals 0. If I told you that, can you solve for x for me? Can you get x all by itself using old school algebra techniques you learned in 7th grade? This is not a trick question. You subtract 30 from both sides. You guys give up way too easy. 11x equals negative 30. X is being multiplied by the 11, so I need to get rid of the 11 by dividing it. So just divide by 11. So x is equal to negative 30 over 11, right? Here's the thing. If I add something like this, then you can't use any of those algebra or those pre-algebra techniques to get x all by itself. So what I'm doing right now is I'm showing you how to do that. And the tool we use is factoring. Let's factor this. X and X. What are the symbols that are going to go in there? Plus plus, minus minus, plus minus. Good. What are the number options that I can choose from? What are the factors of 30? 6, 5, 10, 3, 2, 15. Which one do you want to use? 6, 5, 2, 15, 10, 3, 1, 30. You want them to add to be 11. 6 and 5 do. Perfect. Oh, and that equals 0. So this tells me that x is equal to -6, or x is equal to -5. Right? And the cool thing is this. I can take -6 and plug it into here, and I'll show you something cool. Watch. If I take -6 and I plug it into my original equation, I have x squared minus 11 or plus 11x plus 30. If I plug in -6 into here, that would be, what is -6 times -6? Because I'm replacing all the x's with the -6. Positive 36. -6 squared is positive 36, right? Minus, or plus 11 times -6. What is that? What's 11 times -6? -66. I'll show you. Look. 11 times 6 is 66. So, you guys got that? Oh, wait. Alright. Plus 30. What is 36 minus 66 plus 30? What is that? What is 36 minus 66 plus 30? Alright, fine. What is 36 plus 30? 66
It's 0.
plus -66 equals 0. Awesome. That's true. If I plug in -6 in for x, that statement will be true. What?
Like,
Plugging it in?
so long to
You get good at it. That's what you can do. I'll let you guys plug in -5 and see if that is also a true solution. Which trips me out because -5 works as well, really? Cool. I'll let you plug in the solution to that. But here's the thing that makes it really cool. Is you can graph these things really easily. I told you at the beginning of this that I'm going to show you how to graph these things without making a table. And you asked me, how do I do that?
Yeah, I did.
And I'll show you how. Let's try this problem. Let's take a look at this problem. X squared plus 7x plus 12. That gives me a parabola. I'll prove that to you by graphing that parabola. I think it said x squared plus 7x plus 12. Yeah, right. Here's Desmos. X squared plus 7x plus 12. Alright, let's move this way. We'll zoom in a little bit. Alright, I want you to take a look at that graph, okay? I can get that graph without using the graphic calculator. See how?
Yes.
Let's factor this. Okay. If I factor this, I'll have two parentheses, x and x, plus plus, minus minus, plus minus. What are your thoughts? Plus plus. You're getting good at that. What are the numbers? What are the number choices? 4 and 3. What else?
There's 2, 6, but 4, 3
4, 3 works. Perfect. Okay. If I set this equal to 0, then what is x equal to? Well, x plus 4 is equal to 0, or x plus 3 equals to 0, right? X equals negative 4, x equals negative 3. This tells me that the zeros of my parabola is at negative 4 and negative 3. Do you see that? So my parabola is going to look like this. Watch. If I go back to Desmos, look at where that thing crosses the x-axis. At negative 4 and negative 3. Oh, snap. That's pretty cool. That is pretty cool, huh? I hate to say this, but you don't know what we're talking about, do you? About graphing these parabolas? Probably because you haven't gone through chapter 2, 3, and 4, and 5, which is where we covered a lot of that stuff. But if you can factor, you'll be sitting pretty. I know that we're at 11 minutes, and I apologize, but you know what? I want to show this to you because I think it's important. Let's take a look at this one. Let's find the zeros of this function right here. Parentheses, parentheses, x, x. What am I dealing with? Plus, minus, plus, plus, minus, minus. Not minus, minus. Definitely not. Yeah, one of those. Okay. What are the number options that I can choose from here? 2 and 3, 6 and 1. I'm definitely going to go with 2 and 3. Where do I want? The 3 here, the 2 here, the 2 here, 3 here, the 2 here. Where am I going to put it? Two and 3. Why? Because they're going to add together to be negative 1. If I put the 2 over here, that will add together to be positive 1. Right? All right. Where are my zeros? X is equal to what? No. No. Negative 2 and positive 3. Okay? I bet you my graph is going to look something like this. I bet you. In fact, I can even get even better than that. Where is my vertex going to be located?
Right there. Right there.
Actually, it's going to be located at 0.5. This one's a little bit complicated to do the vertex. But I can tell you for a fact that that's going to be my graph. Here. Actually, you know what? I think that my graph is going to look like this. Let me graph this, x squared minus x minus 6. I'll prove to you that I'm right. Without using a graphing calculator. Minus x minus 6. Zoom out. That's exactly the graph that I showed you. And where does it cross? It crosses at negative 2 and positive 3. That's what I told you it was going to be. Negative 2, positive 3. See? Negative 2, positive 3. Booyah. So all I'm saying, dude, is if you're, I think that's super cool. If you can basically walk around and your like 7th grade brother or something asks you, I need help, I don't know how to graph this, and you're like, you look at it and just be like, looks like this. You walk away. Like, that's it. I did it. And they graph it on the graphing calculator, but how'd you know that? And just like, psh. That's what you say. You should say, psh. I'm just good like that.